All right, thanks, Maria. Yeah, as mentioned, today I'm going to talk a little bit about how Google does permissions internally and how you can do that yourself. So I'm going to go ahead and share my screen. Uh, Maria, is that coming through okay?
Yes, it's perfect. Thank you.
All right, great. So yeah, the title of today's talk is Manage Your Permissions Like Google. I shortened it a little bit to fit on the slide. I'm Jake Mashenko. I'm CEO of a company called AuthZed, and AuthZed is an authorization company. So why should you listen to me? Why do I even know anything about this topic? Well, first of all, as I already mentioned, I'm co-founder and CEO of an authorization company. In the past, I also founded a company. It was actually called DevTable, but one of the things that came out of that company was something that we created called Quay.io. Quay.io was the first private Docker registry before Docker Hub allowed you to store private images. And that was acquired by CoreOS. Then at CoreOS, I was head of engineering for that same division. Eventually, CoreOS was acquired by Red Hat. At Red Hat, I worked as a senior manager in the service delivery organization. You can think of that as like platform engineering and SRE all wrapped up into one. And prior to that, I also have some experience at some companies you've probably heard of, like Google and Amazon. But outside of that, like CV, the real reason that you should listen to me is because I've actually lived the problem that I'm going to be talking about today. So through my work at CoreOS, through my work at Quay, even in the past at Google and Amazon, I've experienced this problem firsthand. So in today's talk, I'm going to talk about the problem that I'm referring to, a little bit about the solution space, what some people are doing in this area. I'll talk about reback, where Google Zanzibar is one example of reback. Reback stands for relationship-based access control. I'll talk about some of the pros and cons of the different approaches that we'll talk about in the solution space. And then I'll explain why we're all in on the Zanzibar model, which is what Google is doing internally. Okay. So just to frame the problem a little bit, I've got here two graphical representations of permissions models. And I'm encouraging you to think about what do these models have in common. So on the left side, we have what I will call a straightforward RBAC system, where user Susie is an editor of document one. And then on the right, we've got this much more convoluted, much more interesting graph, where user Susie has a role. A role is within the context of an org. A role has dynamic grants based on what you're trying to do and the object types you're trying to do it to. So what do these models actually have in common? Well, they're both called RBAC. And this is one of the challenges in the space of authorization, is that basically everybody has different definitions for what these different acronyms, not for what they stand for necessarily, but for what they actually mean in practice. And maybe you've heard other authorization terms like RBAC and ABAC, XACML. So there's all kinds of work done around defining the problem and sort of giving it names in this space. But we often don't start here. So companies will often start off very simple when they're imagining their own authorization or they're deploying their own first authorization system for the application. Most of the time, they start off by building their own, right? So this could be as simple as storing a few pieces of data in a database, loading that up, and then interpreting it in code. At some point, that stops working, right? It could be a soon point, it could be very far in the future, but at some point, it stops working. Maybe it stops working because you have too much traffic now. So the system was built to work for 100 queries per second, and now you're at 1,000 or 10,000 queries per second. Or it was built to support 10 users, and now you have 1,000 or 10,000 or 1,000,000 users. So scale can be one of the reasons. Another reason it stops working is that customers themselves start requesting things that you didn't anticipate. So an example of this would be the model on the right in the past, and I'll give on the right in the last slide, I'll say, but I'll give an example of that from my own past as well. And another time it might fail is if you start entering new geographies and the underlying data store that you're building this on top of is not a distributed data store. So imagine you built a permission system, it works super well, and everything is homed out of Amazon US East, and now you need to expand into Frankfurt or somewhere in APAC. If you need a single unified view of permissions data, often the homegrown solution won't follow you on that journey. So now I want to talk a little bit about my lived experience developing permissions for Quay at CoreOS. So this was the very first permissions model that we built when we created and launched Quay.io. We thought we were copying the GitHub model, I'll put it that way. But in general, everything was centered around the concept of a repository. So a repository is where you would store your container images. And then users could have various relationships to a repository. So a user could be a reader of the repository, a writer of the repository, or an admin. And then if you see the arrows pointing to the right between the different roles, those are saying that when you're considering who is a reader, you should also consider all writers as readers, and you should consider all admins as writers, and therefore also readers, right? So if someone just has admin, we don't want to prevent them from reading the repository. Okay, so this is actually what we shipped with. And within a week, everyone was like, it's great that you copied GitHub's permission system, or you think you did, but we also need all of the really nifty, awesome organizational support that GitHub offers in their permission system. So within a month, we actually built and shipped this much more complicated system. So everything that's new, I have there in red. And what we had to do is we had to build some concept of organizations. We had to nest repositories under organizations. Organizations had teams. Teams had roles within an organization. And then teams also could be directly given access to any of the other roles that a repository already had. So that's what this graph is meant to represent. But the real takeaway here is that it was a lot more complicated than we initially anticipated. So we built and launched that, and the users that asked for it were happy for a little while. But what we failed to realize is that not even GitHub nailed it. And what the users really wanted were they really wanted the ability to have multiple namespaces under an organization. So imagine you're like me and you used to work at Red Hat, and Red Hat had different business units, or maybe even Red Hat itself is a business unit of IBM now. So they really wanted to be able to nest namespaces, and they wanted to be able to nest teams. So they wanted to be able to break down and model teams according to the org chart, and they wanted to be able to nest repositories under like top level parent co, and then slash business unit, slash team, slash repository. And they wanted to be able to hang permissions off of any of those various places in this tree that they wanted to build up. So for example, if you had a top level organization, maybe the admin for that was some super user in the operations department, the COO at the organization. And then as you started to descend through the tree, the permissions would become more fine-grained and more granular and be federated out on like a team by team or a person by person basis. So we never actually built and shipped this version of the authorization model. And the reason that we didn't do that is because we were somewhat naive in our early implementation. We did our authorization based on probably similar to how many of you are doing it, but we did it by storing data in a database and then doing a bunch of SQL joins in order to figure out what you have access to. At the time, we were built on top of MySQL. MySQL didn't support recursive CTEs, so we couldn't do a recursive query to jump through, to walk through and gather up these permissions as we descended or ascended through the namespace tree or through the team hierarchy. So we were never actually able to ship this feature. It was kind of one of those things that it was always on the backlog. It was something that we knew we needed to do, but it was going to require a major refactoring of the way we were doing authorization. So that's sort of the problem as we see it in a nutshell. And now let's step into some of the ways that companies are currently authorizing things. So the most common thing that we see by far is that companies are using embedded custom authorization code in their applications. So they're just writing some code to interpret some data. They're doing it directly in their code base, and then they're making decisions, authorization decisions based on that. If people have decided that this is a bad idea, sometimes they'll adopt a policy engine, and I'll talk a little bit about those as well. And then finally, the new paradigm or the new kid on the block is the Zanzibar paradigm that Google put forward. So first up, this is the embedded auth code in applications. The specifics of the code aren't really important, but what is important is that you can see that we're reaching out to the database every time every time we're trying to handle a request for an object, we reach out to the database and we load who are the authorized users for the object. And then we usually have to reach back out to the same database again to get the data to send back to the user. And then we've got a little authorized method there. It's already abstracted out into its own function. So it's not like a big if-else block embedded in the code, but it is still something that exists within our monolithic application. No judgment if this is how your authorization code looks. Like I said, I've built and launched variations of this in the past, and it definitely works for some scale. So when we break down sort of the pros and cons of writing custom code to do authorization, the biggest pro is it's infinitely flexible. You can do and express anything that your heart desires as long as you can figure out how to write the code for it. Another pro for custom code is once you've exceeded the single monolithic application and you start to break down your service into potentially other services or microservices, you can take that authorized method like I had on the last slide, and you can turn it into a shared library. And you can share that library and compile that library into other services and other applications. But if that code is living within a single service, one of the downsides is that you can't call it from other services. So one thing that we'll often see as a company is going through like a microservices or a service decomposition is that the authorization logic will get tied up into that monolith. And then they'll actually have to expose methods on the monolith for those other microservices to query it about authorization. This is obviously like a huge inversion of priority, right? Like you don't want microservices to be blocked on calling out to a monolith. This is not the ideal by a long shot. Another disadvantage of this method is that if you split this out into a library and you happen to be a polyglot shop, which is you're writing your services in multiple different languages, you need an implementation of the library for all of the different languages that you're potentially implementing in. So for example, if you use JavaScript, Node.js on the back end, maybe you use some Python, maybe some Java, maybe some Ruby, you need an implementation of that same authorization code for all of those languages. And that can often result in difficult and complicated rollouts as well. So if you need to update the authorization code, you need to make sure that you're updating it across all languages and rolling it out to services in such a way that the users are never given an inconsistent view or incorrect answers. Another downside of this method is that you're actually going to your database, your main database, your source of truth, and fetching data on every single request that requires authorization. And not just data, but data specifically about authorization. And this can add additional unwanted load to your database. This was definitely something that we ran into for Quay. On Quay, we did those SQL joins, as I mentioned, and I think the final version of the code, or the code that you can go see if you look at the open source right now, does a join with like 11 different tables. And when we did some analysis, it turned out that we were spending far, far, far too much of our database CPU just joining on these same 11 tables over and over again. This could be like a tall tale. Maybe every time I say it, the number of tables gets a little bit bigger, but it is open source. You can go check out how that works today. And finally, authorization code isn't really the kind of code that people like to open up and change all the time because it's really tricky code. It's hard to verify that you haven't opened any security holes. And it's just not something that your average application developer is really interested in getting down into the nitty-gritty and understanding the nuts and bolts of. Okay. Moving on to the next solution, we have policy engines. So policy engines were kind of the hot new thing on the block probably about 8 or 9 years ago. So what about policy engines? Are they good? Are they bad? What do they do? Often when people embark on adopting a policy engine, their goal is to abstract their authorization logic from their code. And this is a laudable goal, right? Like you can solve a lot of the same problems that we just talked about. You can write your policies in a robust logic language that's formally proven to be correct for a certain class of authorization operations. Since it's usually a network request or you're running it in a sidecar, something like that, you can have one implementation of your policies for all languages. And then you just reach out and talk to those policies over the network. And this works really great when you already have all of the data ready. So imagine if you're writing like a network appliance or an HTTP filter or something like that. Excuse me. And the data that you're making your request based on is already available to you in the form of the IP address of the caller or HTTP headers or the current date and the current time. If you already have all of that data that you want to feed to the policy engine can often give you an answer back in microseconds. Some of the downsides of using a policy engine, though, are that you still have to fetch data from your main source of truth for every request and feed it to that policy engine. And sometimes you're reading a lot more data than you really have to, depending on how you can constrain and how you can draw a boundary around the data that you need to feed to that policy engine. It can also cause a complicated rollout of new policies. If you're using like the sidecar model and you've baked the policy into the sidecar, you need to make sure that you're rolling that out in a really consistent way, or at least in a backward compatible way, such that if two different services are evaluating the policy at two different times, they don't accidentally open up a security flaw in terms of having different data interpreted different ways at different places. And then finally, these languages that you write policies in are powerful. They're very powerful, sometimes even Turing complete. And these can result in policies that are difficult to understand and difficult to write and difficult to maintain. Just to show an example of one of those, I went to the OPA website and I just pulled a Rego script right off of the landing page. I'm going to give everybody about 30 seconds to read through this Rego script and try to have an idea in mind for what this script is doing or what this policy is doing. So I'll go ahead and pause for about 30 seconds. When I look at this policy, I start to look at, all right, well, I see eligible groups, something about locations, a lot of things about locations, actually. And then we've got some kind of roles construct. And then we've got this block repeated 3 times, which I guess it's binding a location to a role record. So if you were able to figure it out, maybe you were, maybe you weren't. But what this is actually doing is this is doing a role binding by location and group name. So the first thing it does is it verifies that the groups are one of the supported groups. So that's group 1 and group 2. And then it gives 3 different locations, and the locations have different roles for each group in each location. And then anything that doesn't match one of those locations or one of those groups results in an empty set of roles that you have access to. So this table makes a lot of sense to me. But this policy was kind of hard for me to read through and for me to understand what exactly was happening here. And as a result of having policies that are written in this domain-specific policy language, one thing that we're being told by our prospects and by our customers is that when you adopt a system like this, the platform or auth team usually ends up owning all of the policies. We talked to a massive organization, and they told us that they were using a version of Prolog or a dialect of Prolog to do their authorization policy. And there was literally one person in this multi-tens of thousands of person organization who was capable and confident in writing their policies. So this is usually kind of an anti-pattern for what we think about when we think about what we're trying to accomplish by bringing in an authorization policy engine. All right, so moving on to the next and final solution in the solution space is Google Zanzibar. So in 2019, Google wrote a paper called Zanzibar, Google's consistent global authorization system. And the core concept of Zanzibar is let's build auth on top of a globally distributed database. So internal to Google, there's a globally distributed database called Spanner. It's ACID. It seems to violate the CAP theorem and like the basic laws of physics, but it is a very solid thing on which to build an authorization system that might need to scale and that might be geographically distributed. I won't pause here to let everybody read the whole paper. It's about 12 pages. It's a really easy read, and I highly encourage you to go read it. But I will give an example of what adopting Zanzibar has allowed Google to do. So if you've ever been in this case where you're writing an email, and in the email you include a link to a Google document, and you think everything is great, and you go to hit the send button, and Google pops up a scary warning that says, hey, someone that you're trying to send this email to does not have access to the document that you've linked. What is this magic? How does this work? How does Gmail possibly know what access my email recipient has to a document that I've merely linked? Well, the answer is that they use the Zanzibar service as a centralized authorization service for everything at Google. And Gmail is able to ask questions about permissions that exist ostensibly within the Docs service. So, high-level overview of Zanzibar. It's a single authorization service for all of Google, like I mentioned. It's dealing primarily with storing relationships as edges in a directed graph, which is what I referred to earlier as reback or relationship-based access control. Then they give their engineers a schema to flexibly interpret those relationships. So we're decoupling the relationships themselves from how they're interpreted to make authorization decisions. And this service at Google, they spend about half the paper talking about performance, and it's throwing up some really impressive numbers. So at Google, Zanzibar is doing 10 million queries per second at peak. And this is as of 2019. I'm sure it's grown since then. These are just the numbers in the paper. They're storing trillions of relationships, and they have a 95th percentile check query latency of 10 milliseconds. So if you know anything about writing applications that are human-facing, usually you want to keep those interactions under about 100 milliseconds. So 10 milliseconds really isn't chewing up a whole lot of that budget at all. And maybe most impressively, for this being a centralized service, they've managed to keep 99.999% uptime. So 5 nines of uptime for this service, which is super important for an authorization service, which is usually in the line of fire for every request. So in an attempt to make this more concrete, and I hope I'm successful there, here's an example of using relationship-based access control to control policy decisions. I don't have access to a DSL if Google has one internally, but what I can show is how you express these things in our own AuthZed's SpiceDB schema language. So what we have here are we have 3 different object types: users, organizations, and documents. And then within those object types, we have relationships. Those are in the red boxes or relations. So we can say that a user can be an owner of a document. A user can be a reader of a document, and a user can be an administrator of an organization. And then I only really have one document level permission modeled here, but you can imagine read, write, view, delete, many different permissions. But the way we're expressing this permission is we're saying, in order to be able to view a document, you need to either be a reader of the document, you need to be an owner of the document, or you need to be an administrator or have the admin permission on the organization that the document belongs to. So I don't know about for you, but for me, this seems like a really straightforward way to express this kind of authorization logic. But then to try to make it more visual, I have a graphical representation of that same policy on the right-hand side. So we can see, I tried to color coordinate it so that you can see relations and how they relate between users and documents and organizations. And then the interesting one is there's the dotted line that connects view to admin. And so that's just showing you that you sometimes need to traverse the graph, go through different objects in order to be able to make the decision that you need to make. So in this case, we're considering what a user's role is on the organization in order to make a decision about whether they have access to the document. And then down at the bottom, I just have some example relationships. So these relationships are basically, the way to read this is that user Sean has reader on document some document. User Fred has reader on the same document. User Jill has owner on the same document. So we're basically setting up edges in a directed graph where we're relating a subject, which is often a user, back to a resource, which in this case is either a document or an organization. And then you'll also see that we explicitly bind the organization and the document together with this relationship down on the bottom of the relationship grid. So by combining these relationships and the policy which allows us to interpret them, we can express in a really natural way very, very complicated authorization schemes. So Zanzibar, what is it good for? I've already mentioned that it's very scalable with traffic, with requirements, and also across geographies because it's built on top of a distributed database. It's very flexible. So within relationship-based access control, you can actually model multiple other authorization paradigms. For example, ABAC, which is, attribute-based access control, or RBAC, role-based access control. Facebook actually wrote a paper about how you can model all of ABAC in RBAC. You also get a single view of permissions for all services. So this is how Google is accomplishing that thing that I showed earlier, where Gmail is able to understand access that only ostensibly exists in the document service. One of the super powerful things you can do when you have a system based on a graph like this is you can do reverse index questions. For example, what can this user actually access, right? So like user Jake is talking to my web app. What documents can Jake see? If you think about how you would implement that in your own code or in a policy engine, you can see how that would actually be pretty technically complicated. And finally, it gives you a really natural way to express permissions as long as the permissions that you're trying to express are dealing with relationships between people and other people, or people and data, or data and other data. Some of the downsides to adopting something like Zanzibar is that it's actually really hard to do with data that's only available at request time. So for example, if your permission decision needs to take into account the IP address of the calling user, you don't have the IP address to store as a relationship ahead of time. So you can't really use that in a graph walk or a graph traversal. We do have a solution to that I'll get to in a little bit, but in stock Zanzibar or in core Zanzibar that they write about in the paper, that's actually difficult. And then finally, it's just yet another distributed system to run. So if authorization is very important to you and a very critical piece of your business, then you'll run that distributed system. But often you might say, well, I'm kind of up to my ears already in distributed systems, so I don't really want to bring this in as well. If you're interested in learning more about Zanzibar, I gave a full 60-minute talk just about the paper and the various sections of the paper for New York City's Paper We Love meetup. There's a QR code there, but I will warn you, it's highly technical, and I break down all of the different distributed systems techniques that Zanzibar uses to get the performance and the uptime that we talked about a little bit earlier. Okay. I'm always an advocate of choosing the right tool for the right job. So there's that phrase where if all you have is a hammer, everything looks like a nail. We don't just have hammers in authorization, we have other things. But just thinking about what the various things might be good for. So I mentioned earlier that network level or HTTP level filtering, because you have all of the data at request time, is maybe a really good fit for a policy engine. And if you have to do comparison of values, right? So if you're trying to say like, are the contents of this shopping cart greater than $100, and taking that into account when you do your permissions checks, that might also be more suited for a policy engine. But where does Zanzibar really shine? So Zanzibar really shines when you're doing traditional role-based access control, because you're able to associate the user with those roles and then interpret those roles all in a single place. It's really great for RBAC with user-defined roles. So if you want to give your customers or your users control of what those things actually mean, you can do that with Zanzibar as well. We have an example of that in our playground. If you want a single consistent view of permissions everywhere, Zanzibar is great for this, right? It's a network service, it's centralized, it has all of the data ahead of time. And it's really great at being able to do that. And finally, if you need to feed billions or trillions of facts or relationships to your policy solution in order to make a decision, that's really difficult to do with a policy engine. So if you try to check out what the research is on scaling data log to billions or trillions of facts, you'll find that this is actually cutting edge data log stuff and isn't really supported everywhere. And then on the Zanzibar side, I do have a little yellow warning sign there because stock Zanzibar isn't good at those things. But we've built an open source service called SpiceDB, which is everything that Zanzibar talks about, plus a little bit more. So SpiceDB is our open source love letter to Google Zanzibar. You can find it at auth/SpiceDB on GitHub. It's fully open source. It's Apache 2, which is a very liberal license. We have about 4,000 GitHub stars, over 3,000 commits. We have 1,500 users on our Discord who are in there talking about authorized software. And we have over 40 contributors from multiple companies across the industry. I've been kind of alluding to is we have a thing called caveats, which allows you to attach small bits of policy to individual relationships. And I have an example of that on the next slide. We also have a few additional APIs that make it easier to work with this solution, giving you those reverse indexes that I talked about and giving you information about how permissions are changing over time. And we've also got a really thoughtful, really great schema language that we're constantly being told is sort of industry leading. And we definitely want you to come to contribute, to use it, to do whatever you want to do, but just get involved in SpiceDB and in the whole Zanzibar movement. As promised, I have an example of caveats. So in this example, we just have a permission system where we're trying to decide who can unlock a car. And in this case, the owner of the car can always unlock it, but the cleaner of the car might only be able to unlock it on certain weekdays. And then we have a single relationship where we say that user Jake, in this case, I'm the cleaner of the car, is only allowed to be the cleaner on Sundays. And then the specific car that we're talking about in this case is a Toyota Camry. I don't know why I picked that, I just did. So then we can see that as we're traversing this graph, we'll take into account what day of the week it's being called on. So this is really how we can fuse some of the best concepts of policy engines with the overarching Zanzibar model to get sort of a holistic solution that works for all those cases that I mentioned earlier. And since I'm a little over, I'm just going to quickly wrap up. We as a company at AuthZed, we're all in on Zanzibar. We're literally betting the farm on this model. This is all we do. We're 100% focused on authorization and on solving authorization this way. And we'd love to talk to you on our Discord about Zanzibar, about our implementation SpiceDB, about authorization. Maybe you're not even sold on the model and you want to just chat about authorization. If you have ideas for what we should be building or what we should work on next, if you have use cases that maybe we haven't thought of, we're always interested in collecting and understanding those better. And I just wanted to mention that we've already helped companies of all sizes adopt the Zanzibar model. So don't think, oh, well, we're a very small company, or, oh, we're a giant enterprise. This would never work for us, because the model actually scales quite nicely all the way up and down the chain. And that's it. And now I'll open it up for questions.
Amazing. Thank you so much, Jacob. And we have the first question in, have you heard of Ori, Kratos, Oathkeeper, Hydra, and what do you think of it? How does it compare to Zanzibar in your opinion?
Sure. Yeah, I've definitely heard of Ori. So Ori, Kratos, and Oathkeeper, those are identity solutions. So those are authentication and not authorization. They do have an authorization solution called Ori Kato. And Ori Kato is another implementation of Zanzibar. It doesn't have the extensions that we do, and it supports and when I say we, I mean our SpiceDB open source. And it also doesn't support a number of the backend engines that we have. So we're built on top of Google Cloud Spanner, Postgres, CockroachDB, etc. So like I said, we're 100% focused on authorization. And this is just part of what Ori is focusing on with their entire suite. Can SpiceDB integrate with existing authorization solutions like Keycloak? So this is from Sarish. I believe Red Hat is integrating SpiceDB all on their own with some services. I'm not sure if they're integrating it with Keycloak directly. We have in the past taken something like Open Policy Agent, and we've made a network call out to SpiceDB as one of the places that you can go to, as one of the options that you can do in your policies. So if keycloak has a similar extension point, then it seems likely that it would be able to call out to SpiceDB as well. Okay.
Nice. Just if you have any other questions, maybe let's give 30 seconds to people who are typing in just to reflect. We'll send over the webinar replay and slides to everyone who registered, and you'll get that in your inbox tomorrow. You can also ask questions later on to Jacob after the webinar in the platform engineering Slack channel. Let me resend the link once again so you guys know what I am talking about. And we have 2 more questions coming in. 1 more question, sorry, that one we already answered. Sometimes authorization data and business logic data get mixed up. What can be guidelines to think over it?
Yeah, so fundamentally, I think the question is, how much of our business logic should we try to encode in our authorization policies? And the answer there is obviously going to be, it depends. We see a similar problem in programming languages when we think about how much information do we try to encode in our type system. And there's a similar solution space there. Certain things are very naturally fit into the authorization paradigm. So for an example, an entitlement, or if a user is adopted into an experiment, something like a launch darkly, those are inherently authorization decisions as well. Does a user have access to this feature? Yes, no. Entitlements, did the user pay to be able to use this software? Yes, no. But I really think you would want to stay away in terms of business logic around like, this user can only, yeah, I don't know. It's hard for me to come up with a counterexample because I live and breathe authorization stuff. But yeah, there's definitely things like this user should be able to, well, by framing it as this user should be able to, it's already authorization. But a user drawing on a canvas, whether they're allowed to draw on a canvas, yes, very clearly authorization. Where they're allowed to draw on the canvas is probably more of a question for the actual application itself.
Thanks. How does SpiceDB measure in terms of the Zanzibar metrics that you had on your slides? Any customer implementations at scale?
Yeah, we definitely have customer implementations at scale. I don't remember offhand which ones I'm allowed to mention, but you can go to our website at authz.com and there's some customer logos there. And then if you also check out our blog, we have a blog post where we took SpiceDB to 1 million queries per second, over 100 billion relationships, and saw very similar performance numbers to what Google sees with Zanzibar. So we haven't taken it all the way quite to 10 million QPS and trillions, but we've gone pretty far. As the CEO of a startup, we took it as far as I was willing to pay for the Google Cloud bill to test it.
They tend to be expensive, I heard. Should we use languages like Cypher more to model these systems rather than always defining a new DSL for every tool?
Yeah, that's a good question. Well, I think Cypher is a new DSL for a tool very similar to this. So it's like, it's more of a question about should the industry standardize on one or the other? I think if you look at some of the other people who are out there trying to do Zanzibars, you can see that they've taken heavy inspiration, is the nicest way I can put it, from our policy language, from our schema language. So I think we've really put a lot of thought into how to express things in the relationship-based model. Something more like a Rego or a Cypher that's more policy focused, I don't think would be a good fit here. I think you'd really have to try to like force a square peg in a round hole to try to get that to work, to represent the relationships the same way we do in our system.
I'll read out one question from the chat. What if list of authorized objects is very long? How will SpiceDB behave?
Yeah, so if you're doing an individual check, so if you're just asking, can this user access this thing? All of the other data, even if it's an authorized list of users, a very large list of users that has access, or a very large list of resources the user has access to, that one check will only consider data that's relevant for that check. So this is actually one of the strengths of the system, right? Is that we don't have to feed all of that data to the policy to figure out if it has access to one thing. We can just literally consider the edges in the graph that are related to the start and end point that we're trying to consider. To make it concrete, if I have a document, my secret notes, and then I want to know if another user is allowed to access my secret notes, it doesn't matter how many documents I have, or it doesn't matter how many users I've shared it with, because we're only looking for that one relationship between that document and that user. So that's one of the keys that allows it to scale to trillions of relationships.
Can you integrate Austat into Kubernetes RBAC?
Yeah, good question. The answer is somewhat. So Kubernetes does have authorization webhook functionality. So you can call out to an external service to make authorization decisions. One of the tricky parts is that if it needs to be based on the data in Kubernetes itself, it can often be hard to synchronize the data in SpiceDB with what's happening in Kubernetes. We ourselves are building a proxy that we're going to use to front the Kubernetes API that will keep track of mutations to the Kubernetes API. So for example, if you create a new namespace, it'll also write an edge in SpiceDB at the same time that says, this user is the owner of that new namespace. And then we can use that to gate further accesses. So instead of integrating on the back of the Kubernetes API, we're actually just proxying the API and doing all of the authorization ahead of time.
Cool. And one more question. Have you seen Auth0's OpenFGA, which is also REBAC? If so, how do you think its capabilities compared to Auth0?
All right. Well, yes, of course, I've seen it. This is a direct competitor to us. So you can take my answer here with a huge grain of salt. I'm obviously going to be biased. I think because our solution has been in the market longer, I think it's more mature. So I think we support more data backends. I think our policy language is better. And we've also proven that we can scale it to the numbers that I was talking about earlier. But like, I'm sure if you asked an Auth0 OpenFGA engineer, they would have a similar list of reasons for why they think their solution is better. So I would just say, like, everybody has to kind of do their own homework and decide what they think the mature player is in the space.
Makes sense. With that, we finished our round of questions. As I mentioned, you can reach out to Jacob on Platform Engineering Slack. I sent over the link in the chat. Also, next week, we're going to have a webinar. These webinars from the platform engineering community are every week. We're going to talk about designing respectful abstractions. You'll also receive the link to like the next webinars that are coming up in the follow-up email together with the slides and replay to this one. Many thanks, Jacob, for leading this very insightful presentation. I really liked how you structure it and the Lego script. I think it was very cool. Yeah, hope to see you. I don't know if you're attending KubeCon or any of you guys, but hope you have the great rest of the week and stay safe. Bye.
All right. Thank you so much for having me.
Thank you.